In the first part of this series, we used functional decomposition to break down one big method into a series of smaller, more sensible methods. In part 2 of this series, we looked at an idea that was implicit in our design, which was the idea that a search is either enabled or disabled, and we made that an explicit property. That also improved the quality of the software. Now we want to deal with what I consider to be the most important problem, which is that the main application really has two parts, input and output, but these are not explicitly represented in our program. One way that we can think about this is cohesion. We can look at each of these fields and see how often they are used, that is, see which methods use them. So let's look at the executor, for example. It is a field of this application, which means it's an essential part of the main application. However, if we look at where it's used, the only place it's used is here in this execute query method. Similarly, we can look at the result area. Well, where is it used? Luckily, the sidebar here gives us some clues. When the query is executed, we reference it, and when it's created, we reference it. So what we have here is a class with low cohesion. There are fields that are used very rarely within the methods that exist. That's not exactly a smoking gun, but it is a good indicator that something is wrong. If we run the application again, we can see the UI is really split into two parts. The top is sort of an input control, and the bottom is sort of an output control. Again, the structure of the code doesn't reflect that at all, and that's something I would like to see, because in my mind there's two parts. In my code, it's all meshed together. And to be very clear, we have methods like configure search enabled property that deals with the input, create query area, input, create search button, input. Execute query is sort of the glue between the two, and this is what actually produces the output. What I'd like to do now is create a separate class that represents the control area, that region at the top that deals with my input. In fact, I need a slightly better name for it, and as you know, in programming, naming is perhaps the most important step. So I'm going to call this the query control. Let's start working on the class to represent that. What kind of a thing is this? Well, again, think about that application. Here, it is a VBox that contains these two elements, an HBox of these two, and the search button. So I'm going to go ahead and as my first pass say, this is that VBox. Make sure I import the class. Now there's a couple different ways to move forward from here. What I'm going to start by doing is pulling parts out of the main application and plopping them in here, even though they won't work initially, but it'll give me a point of reference. We know we need these. And things like the query field and the search enabled, those also belong in the query control. And the reason I didn't cut them out of this file is I want to keep this the way it is in case I need to go back and check something. I also, of course, have version control underneath me, but better safe than sorry. Let's make a constructor for this query control. One thing this will have to do is create what I previously called the query area. It also has to create the button. Notice that I have a bit of a naming problem. Sometimes I'm saying query and sometimes I'm saying search. I may as well change this variable to search. I know that at the very least I want these two things to be in the VBox, so let's go ahead and do that here. At some point I also need to configure the search enabled property. Let's go ahead and do that in the constructor as well. Let's see how we're doing so far. Our constructor is creating the horizontal box that contains the label and the field. Execute query, of course, doesn't exist here, But it's not the query control's job to do that query. Instead, I want to think about this from the perspective of event-driven programming. When I click on the button, or when I press enter inside the query field, I'm going to generate an event, and I'll have the main application watch for that event. This is, of course, an instance of the observer design pattern. It's the same pattern that allows all of the events to work here. For example, when we set the on action on the button. Now, in order for that to work, I have a couple different ways to move forward. Another way to say that is there's a lot of ways to reify the observer design pattern when you're using Java and JavaFX. I'm going to take an approach that in some ways is a little old-fashioned. There are some parts of the JavaFX API that we could leverage here, but I find them to be a little heavyweight, and I think it's easier to get the idea if we take a more traditional approach. I'm going to say that there's such a thing as a query control listener by defining an inner interface. Using an inner interface here is simply a convenience. It means that the full name of this interface is queryControl.listener. An agent that listens to the query control only needs to know one thing. When is a search term specified? Public isn't necessary here because this is a public interface. And it seems like we may as well actually send the search term along with this notification. In order for the query control to be able to send events to its listeners, we need to have a way to keep track of those listeners. So I'll make a list of listeners. We need to have a way for other agents to join this list, that is, to subscribe for those events. In part 1, we talked a little bit about defensive programming. Here's another good place where we can use that strategy. In order for this to work, that listener had better not be null. So I'll put in an assertion here to ensure that's the case. Finally, I need a way to fire this event to those listeners, and I'll do that with a private utility method. Notice that we only know these listeners through the interface, so the only method that makes any sense to call here is onSearchTermSpecified. Now let's go back down to our event listeners. The button is probably the more straightforward case. When I click the button, what do I want to do? Well, no longer do I directly execute the query. Instead, I fire the event that the search term has been specified. The way that I've written this assumes that I need to send in the term here, but in fact, I can save myself an argument by determining what that is here. Now let's go to where we listen for the user to press enter and do the same thing. We have a couple of warnings in this file, but that may be because we are not yet using it. So let's go back over to main application and try replacing its approach with the query control approach. No longer will we have these, nor this, nor the query field, nor search enabled. When we create the UI, we can replace these with this. Notice that execute query won't work anymore because it was depending on the representation of the search term inside of query field. Let's add a parameter here. Okay, the final piece of the puzzle should be to create a listener that listens to the query control for when a search term is specified, and then calls execute query with that term. Here is the verbose way to do it. And I wanted to show this to make sure that those of you who might be a little shaky with how lambda expressions work or how function references work can make sense out of this. What these lines are doing is creating a new anonymous inner class which implements queryControl.listener. The object that's created is subscribed to the query control as a listener. And when it receives this event, it's going to delegate that to execute query. Now there is a slightly shorter way to say the same thing. The lambda expression here is really just syntactic sugar around the longer form. Because my listener interface only has one method, defined here, we don't need all of the extra syntax around this. However, the effect is still the same. This is instantiating an anonymous inner class whose instance is then sent to the addListener method so that when the search term is specified, execute query will be called. Let's try it. Notice that my interactions are still working, even though now this part here is simply a query control object. I've moved that responsibility to its own class. That's a good thing. If I press enter, we continue our search. If I click search, we search again. Well, that's pretty good. But before we review and try to make conclusions based on that, notice we have yet to go through and ensure that our code is following our standards. And that's important because right now you can see we have many compiler warnings. A lot of these are simply unused imports. We can use Ctrl-Alt-O to organize imports. That gets rid of most of them. Looks like there's one left here. Oh, this is a case where we don't even need a lambda. We could actually just use a method reference. Once again, this actually does the exact same thing. Okay, let's start at the top. Main application has been greatly reduced. Now it only has half the fields, the executor and the results area. Start didn't change, but create UI is a bit shorter because now it's just creating the query control and delegating responsibility to it. Execute query is mostly the same, except now we have one parameter, and we still have our results area at the bottom. Let's go over to query control. If we give this a once-over, we can see there's no compiler warning, so that's good. We have our public type that we're exporting declared at the top. That's pretty conventional. Our private fields look good. This can also be a final list, and you know I like to put my final fields together. Notice that the only JavaFX widget that it needs is text field. The constructor is pretty short and clear. We have our method to manage our listeners and firing events. This is the same as it was before we extracted it. In fact, so are these. So I'm pretty happy with that. I think our result is quite good. The important thing to think about is, if there were a change needed, where would we have to go? If we wanted to change how we specify queries, for example, adding autocomplete or speech recognition, well, that clearly goes into the query control. Right now, if we wanted to change the way that our output is shown, that's in the main application. Well, that seems like a problem too, doesn't it? Why should the main application know that our output needs to be specified as a bunch of new line delimited strings? Wouldn't it make sense to make result area itself a class so that there's a class with that responsibility, and if we wanted to change it, we'd know exactly where to go? You bet your boots. I don't want each part of this series to get too long, so I'm not going to change the result just now. However, I think it would be a great exercise for you to see if you understand all the steps we followed so far. I hope you enjoyed this part of the series. To me, this is the most exciting part because we can follow all the good principles of object orientation, like the single responsibility principle, good functional decomposition, good names, small methods. It all comes together in this beautiful refactoring of a completely made-up application. Happy programming!